Welcome back to our session, Hic sunt dracones, about improving knowledge exchange in the semantic web with linked open and fair data, with our second part. Again, a reminder, the talks are limited to 20 minutes, 15 for talking, 5 for questions. If you're not talking, please mute your microphone, and the questions can be asked in the conference system. The session is part of our special interest group on semantics and loud in archaeology. And if you're interested or would like to join, check out the link at the bottom of the slides. Our first presenter is Keith May, who is going to talk about an open and shut case towards shared standards for stratigraphic data and heritage linked data, or LOD. Please, you have the word, Keith.
Thank you, Martina. Can you see that?
Yes.
Okay, hello everybody. And the first thing I'll say, I started with the title An Open and Shut Case, and when I was looking for something to kind of illustrate this, I was thinking, it sounds like a bit of a Sherlock Holmes case, so I'll go and look for some data related to Sherlock Holmes. And I went to my own company's website, a Historic England website, and I looked for an image that was supposedly Sherlock Holmes, or it's Conan Doyle's house, and I came up with this, which seemed like an ideal introduction to sharing data, because it said I couldn't have it. Luckily, hopefully, it will let me have it, and I'll get to advance the screen. Yes, with my button. So, welcome to Open and Shut Case. As an overview of what I'm going to talk about, it won't be Sherlock Holmes. Sorry to disappoint anyone that thought it might be. I'm going to go into a bit more detail about a project I've been funded by the Arts and Humanities Research Council called the Matrix Project, which Kerry Binding referred to earlier on, and go into a little bit more about that as we go through. Basically, I've used this as a test case, an example looking at stratigraphic data to try and look at some of the issues around reuse and standards for data. And as part of that, we've been building, or Kerry in particular has been building, a prototype tool based around sort of matrix stratigraphic analysis to see how we can explore some more of the issues around that. But as part of that, of course, we're also exploring the use of linked open data within that tool. So I'll give you a view of that as I go through, and then talk more about sort of some of the issues relating to the reuse of data, stratigraphic data. Particularly, I'm working with colleagues at Sheffield University, Professor Caitlin Bucker, who's known for her Bayesian chronological modelling and how that relates to sort of fair use of stratigraphic and chronological data. So, starting with the idea of sort of like the problem, which relates to a number of projects going on at the moment. I'm also involved with the SIADA project. Some of the others here I think are as well, about reuse of archaeological data across Europe, and obviously it relates to Ariadne as well. And I've gone into the idea of using process modeling. I don't expect people to read all the detail of this, but the idea is to sort of model common steps in what we call the analysis process. So this is more about how data is used once it comes off site, which I'll talk more about why I picked that, but in particular it relates sort of issues that we've had in other projects relating to some of the data reuse that we tried to do. Part of my project really has been to go and interview the top sort of 10 major archaeological organisations across the UK. For those that know, people like the Museum of London, Wessex Archaeology, Oxford Archaeology, there's sort of some major contracting organisations. And this has sort of helped me draw what this diagram is trying to show is that there are sort of differences in methodologies, and to some extent this particular process modelling showed the difference in how the financial nature of the projects can affect the sort of data that appears in the archives. So basically, just sort of the two swim lanes here show that research funded projects tend, if you've got enough money, you get a publication out of it, and the data you produce is a more sort of linear process. It's not as straightforward as it shows here. This is a high level model, but basically you get to analysis with funding for publication archive. If you're going in a commercial operation, there's a kind of hiatus which we often find where people, and it depends on how much archaeology there is on the site, but basically where that diamond is, the idea being that people often just produce a short, what we call a short report. In the UK, it's often called an OASIS report, and that gets sent to the archive like ADS. But often the more analytical, the phase in, the dating, the public, all the work that goes into writing a publication doesn't necessarily happen. So we're looking at investigating the semantic mappings between these different levels of concepts and the different processes. And this just illustrates that you get stratigraphic data at these different stages in the process. It's analysed, put together, then phased. The actual dating, the things they talk about in terms of David and Carter talk about the coins, is often only done once it comes off site. Then the data goes through publication into archive. But my argument here is also that we should be thinking about that the archive data is often where people start the next excavation. In fact, I would argue you should always, first thing you should do before you go and stick a spade in the ground is check that nobody's actually dug anything around there before. And so although the diagram I have here is a kind of linear process model, it also refers to other things I've said. People have seen this slide before. There's a cycle of research in this where you need to reuse the data. This is a, dare I say, more detailed version. Again, don't need to read all this, but basically the software I'm going to show later on in this is effectively, we did this with Kerry in mind in order to sort of show the main data. The green boxes are sort of the main data items we're trying to work with. And what people do with stratigraphic data, they check it when it comes off site, but then there's this iterative process of grouping. I think Olivier kind of alluded to some of this in their modelling as well, that it goes through this kind of grouping. I mean, with buildings, it's quite interesting whether the grouping is the same as below ground archaeology, but people want to phase it, and to do phasing, you basically need to interpret the kind of layers, the kind of archaeology you've got, and what dating evidence you have. So those are key concepts involved. And again, just to reiterate, it's a sort of cycle, an iterative process of data coming in, being worked on. Often the dates change. The phasing will change if certain dating comes in at different stages. If you get the coin dates early, you'll have one set of assumptions or interpretations, and then suddenly some radiocarbon data may come in later, and that could change quite dramatically what the data is later on in the process. So going sort of how this relates to standards, the real key here is that I'm advocating that we need data in a reusable format in sort of database tables, and that just having an archived image such as like a PDF copy of these matrix diagrams is not enough for people to actually go back and really fully understand all the relationships between the data if you want to understand the dating evidence in relation to what the stratigraphy is. So I'm arguing really for a consistent format for preservation, interchange, sharing and reuse of the stratigraph, particularly the stratigraphic relationships, the above-below relationships that you get in archaeology. And then this question of formats, which I'll talk a bit more about, but we're kind of looking to formats like RDF and JSON. Just to give us flavour again, those don't know, when I talk about matrix, this is a sort of a reasonable example of a matrix, and it also just allows me to mention that we've been working with, obviously I work with things like CDOC CRM and particularly the temporal operators like the Allen operators, but also the temporal primitive operators that have also come out of CDOC CRM work. But at the moment, these matrix diagrams don't have any of these other relationships explicitly recorded in data. What archaeologists only record is the occurs, before, after and equals in terms of stratigraphy being above, below or contemporary with. And again, just for those that may not know, that we've done modelling on this sort of in the past in a project called STAR, and a lot of the issues around the stratigraphic data arose in trying to find kind of consistency in the data sets. We kind of proved the semantic technologies of being able to query across data and see which archaeological objects were in layers before and after other layers stratigraphically. And Kerry, this is more work that Kerry Binding did as part of that browser work. But we only got so far because there were still issues around how that data was actually held in data sets. Now I'm going to give you a quick talk through. Kerry showed a bit of this as well, but this is actually more of the application. They're calling it phaser at the moment. I think the name's up there somewhere. And this is showing how we actually are importing the Periodo. So Kerry showed we use in heritage data, but in fact what Periodo allows you to do is check for the linked open data. All these different period terminologies are available on Periodo. As you can see, there's a lot. I'm scrolling through them very rapidly, but I think, I'm not sure if it says, there's 139, it does say. And I'm just going to search the one that we use in the UK, which is at the moment the heritage data vocabularies online. And then that, you'll see that picks up the actual data items in that vocabulary, the periods in the vocabulary. And then I'll just click on it and import those into the tool. And then you can see, I think initially there weren't any periods. Now on the periods tab, we've got those 42 terminologies for periods in, with the date ranges, as Kerry mentioned in his. And then I can add that if I want a particular period relating, we can add periods to the context, the subgroups, the groups, or the phases. In this case, I'm just going to add it to a single context, which some people do. I mean, that raises the point that practice is the thing. Well, part of the project is about understanding what people do in practice, and some archaeologists will add periods to their context, particularly if they have no other dating evidence. They might have a stab at saying, well, it's below an Iron Age context, so I'm going to say it's Bronze Age. At that point, I should move on. I think it will repeat. And just to kind of, again, talking about the sort of the importance of the semantics and talking to people to understand how they're using terms in their data. This is just picking up on Tom Dye and Caitlin Buck's work, and Tom in particular has built this software HM, which I guess stands for Harris Matrix. It's a sort of matrix building tool, but it's using data to graph model chronological data. So he's using directed acyclic graphs on this, and he refers in chronological terms the association of dating evidence, and he says direct association is what, in fact, when I talked to him, I realized that direct association in their terms is what archaeologists would call contemporary. Disjunct association is what archaeologists would call residual, i.e. the dating's coming, the context, sorry, is older than the context and thus disjunct, and disparate, the dated evidence is younger than context and thus disparate. And it's just important in terms, again, of how we relate this data together when we actually have to do querying across it, that we get the right semantic. Just to give a bit more of an idea about than just that we're going to use Periodo. Here I'm going to show an example. We want to include dating evidence, and part of my project is again going back to the actual archaeologists as well, and try to ask them how they want to actually include dating evidence. Now the trick here is that I'm going to hopefully show them that the advantage of using the period terms would also be advantageous if they use them for their dating evidence. So at the moment I haven't put the links to the heritage.org typologies here. We are presumably going to leave the option to put something in manually, which I'm showing here, but you argue the case that it would be a lot better to put a controlled vocabulary there if you've got one. But there are questions around it. And then interestingly as well, you can see there's a bunch of coin dates up there, which is why I was interested in what Carsten and David were showing. Here I'm just adding the dates in. We are going to include the question of whether the dating is residual or intrusive as part of the options in this, although I would tend to argue that in most phasing evidence archaeologists don't actually bother to put that in because they won't use that dating evidence if they think it's residual. Okay, so I guess in the context of this session what I'm arguing is whether, as well as the dragons in the data, are there bigger dragons in practice? The actual dragons, I think others may have alluded to, are as much in the way people do things as opposed to whether they're just in the data just reflects the practice of what people are doing. And in a way, one of the things I'm also is that we are handling data from the analysis, because to some extent, I don't think the issues are in what people do in excavation. The excavation practice is relatively uniform because what people do on site, they have to all do it roughly the same way. Otherwise, they really would have not be able to cope with the data when it came off site. Some of the inconsistency, or more of the inconsistency, I think, comes in after this data leaves site. Now, the argument has always been, oh, the excavation is unrepeatable. We can't repeat what we do. We can't go back and dig the site and get the data out again. Well, that's true. But once the data's off the site, we can use it again and again because it's the same data, and what we do with it is repeatable. Therefore, we should hold that data in a reusable way. And I would argue we need a more consistent model for what archaeologists do off-site in analysis. Just to add to that point, when we went looking for stratigraphic data in our research, one of my PhD student, Bryony at Sheffield, Bryony Moody at Sheffield, went to ADS. We searched, she hunted through all the data, and you might say, okay, we looked for data tables. Well, the data tables weren't there, must be all in the matrix diagrams. We looked for matrix diagrams. They got 153 out of 10,000 project reports had a diagram. So it ain't in the diagrams either, and I think it's missing, frankly. So to sum up, how much longer have I got? Does anyone know? I thought I had a clock, but I don't. I would argue that we're putting a lot of data into our archives, and our archives need to be holding the right data. There's no point putting loads of data in digital archives. If we haven't even got the stratigraphy, which is the skeleton of the site, then I don't think we can actually put the rest of it back together anyway. So I'm arguing for more consistent standards. I'm asking that the data should be more reusable. It's fit for purpose, basically. If we're saying that we're going to reuse the data, then we need... I'm not saying that the PDF images of a matrix aren't useful. They are useful to be able to see the matrix, but you need the data as well to go with it. They're not. I wouldn't want to see PDFs just on their own, because then you'd have to re-key all the data back in, which is a nightmare. And I'm kind of advocating for this. So I'm talking with Dr. Edward Harris, the actual originator of the Harris Matrix, recently at the Society of American Archaeologists conference. We're kind of arguing for an international convention on how this data is actually recorded, particularly how it's archived and made available, so that we have more consistency on records internationally, because some of it is used for joining up in projects like Ariadne. And I personally argue something we're advocating in the UK now is something called data management plans for projects to make the fundamental archaeological data more sustainable. At the start, people set out what they expect their data to be used for and make it more findable, accessible, interoperable, and reusable as part of those data management plans. And just as a reminisce, as I was picking these slides together, I found this old slide which I used to say was an indication of the archaeological archipelagos, and it says, where are the dragons? And I realized that I knew where the dragons were, but I just hadn't put them on because they were on that island at the bottom that wasn't joined up. But what I didn't realize, that maybe some of the dragons are still lurking, unfortunately, in our archives. Thank you.
Thank you, May. Apologies for not indicating the time to you. So it's 3 minutes left for some questions.
I can't see the question.
Yeah, I think there's no question, but I have one. Do you think that maybe it is time to get a group of people together and establish a standard format for Harris matrix? Something like, for example, in the linguistics, there's a TEI standard for text annotations, and maybe for a Harris matrix, it might be the time to develop some kind of data model in file format.
Well, I'm less concerned about standardized the matrix in the sense Harris has done that. All Harris's laws and principles are there. Read Harris's principles of stratigraphic analysis, they're there. It's about the data, the digital data that is held in database tables. That's where the variation lies.
That's what I mean. That we get like a standardized format for this kind of data.
It's how should I say it? It's less about has to be a standard. There are key, what I would argue, there are key fields that need to be present.
Okay.
It helps if people would say they label them all the same way, and we know that when someone says above, it's above, or but we can kind of deal with that as long as they consistently put that data in as part of the archive. And unfortunately, at the moment, it doesn't happen. Certainly, what tends to happen is you either get the process data. Jeremy Huggett alluded to this, like geophysics, in the way that you could have the process geophysics, but then people always argue you need the raw data to see how they process the geophysics. And I would argue that to some extent, stratigraphy may be similar. You want the stratigraphy that comes off site, but you need that to see what people had on site, the raw, and then basically you also need to see how the phasing has been derived, with how people have done their grouping in order to arrive at their final publication, and the interpretation, the final phasing and interpretation relies on those different steps, as I say, through the process. And really, if you really want to understand how they've phased things and grouped things, you have to have those different data sets. And some people are doing it to a degree, but it's not consistent. And that's why when you come to link up data sets from different projects, and that's why I think I asked some of the question I asked about the building question about how easy was it to get the stratigraphic data for the building. That's the bit that we found from our STAR research, our semantic technologies research. Unfortunately, the data's across projects doesn't match. I understand that archaeologists first and foremost focus on the site they're digging. I would too. You maximize the data you get from the site you're digging, but I'm asking for people to also think about, in the longer term, how it is we need to share that data with other sites.
Sorry to have to interrupt you.
That's fine, I finished.
Could you please have a look at the written questions and then maybe write answers directly to the questions?
Oh, there are more. Okay.
Yes, there are more.
No, you said there weren't any. Sorry.
Yeah.
Okay. Thanks.
No, they came up while you were answering. But in the meantime, we're going to move on to our next talk by Florian Thierry about Hic sunt dracones, how to make modern data dragons loud and fair. And in the meantime, Keith, you can answer in the chat, I think. Okay, Florian.
So hopefully you can see my screen in full screen. So hello everybody. I want to talk today about modern data dragons, and this talk is together with my boss Alat Mis, and we are both working at the Römisch-Germanisches Zentralmuseum in Mainz. And maybe you all know that whereas SQL technology may cover just as well the F, A, and R capabilities of FAIR principles on local systems, but web-based interoperability and open access is clearly the advantage of the RDF on linked open data technology. And enhancing SQL databases by applying linked open data technologies enables the application of the RDF standard for interoperability, semantic modeling, reusability, interlinking of data, and open access by offering a Sparkle endpoint. And yeah, we all know, because we're in this session, that the relevance of LOD and the semantic web in archaeology has increased in the last couple of years and will hopefully increase in the next couple of years. And maybe you have heard about that. The CAA community established the CAA Special Interest Group on Semantics and Loud in Archaeology, with a short called SIG Data Dragon. And if you want to join us, just check out our website on datadragon.link and go to our GitHub page, where you can just add your name and maybe your email address, and then we will contact you and we'll maybe start after this session really nice work into this special interest group on semantics and loud in archaeology. Would be great. you all know that there is an amount of unknown but qualified data, which is available but hardly findable. And we call that also in this session call the modern unknown data dragons. And as maybe shown before, they are hidden in their lairs, and we are trying to lure them out and just give them free and use all the data. Furthermore, archaeological data is often characterized by hidden assumptions as well as vague and uncertain statements, which have to be made visible by using, for instance, semantic modeling. And Carsten Tolle and David Wick-Wolf just showed it in the first part of this session in an example of numismatics. So it's really, really interesting, and we'll go a bit more in detail in the next couple of slides. And the transformation process from relational structures into linked open data has to be simple and applicable to other databases and modeling structures, because most of our data are just stored right now in SQL databases, not in graph structures or even in triple stores. And as a consequence, the resulting data should be published as well as being made findable and accessible in catalogs of archaeological resources. So what are this talk about? So I will just try to talk about methods and workflows to achieve linked, open, usable, and fair data with the example of the Samian research database and the Free Dragon catalog, an API. So let us start with the Samian research database. What is this database about? The online relational database Samian Research contains 250,000 finds of potter stamps from all over Europe, which you can see here on the left picture with the dots and the amount of things that we'll find there. And South Gaulish potter stamps may occur on different sections of the limes in different parts of Europe. As you can see here, Hadrian's Wall, and yeah, there are a lot of other limes sections, as you all know, and they can do a lot of interesting stuff there. Alatmes just showed something on a relative chronology modeling using our alligator tool in another talk, which was parallel to the first part of this session. And the Samian database is structured right now in a relational database and accessible by online querying and editing masks, which were developed from the late 1990s onwards. You can see here just a simple drop-down menu where you can just look up for a potter and so on. It's, yeah, if you just look at that, you can obviously see that it is something out of the late 1990s. And the cool thing is that data entries are trained in workshops and continuously curated by an active international and scientific research community. And you can see here some pictures from workshops which has been held, for example, in Pisa, Italy, Clermont-Ferrand in France, Lisboa in Portugal, Zagreb, Croatia, and in Cluj in Romania. Although the series of interfaces comprise a RESTful API and WFS, but normally research software engineers would expect also linked, open, usable data machine readable interfaces. So why do RSE try to use, want to have that? Because with this approach, we could do analysis combining distributed linked open data repositories, like here, Rome Open Data. You can see here in the left picture, all the red dots are Pisa Samian from the Samian research database, and all the black dots are Amphora Russell 6B dots from Rome Open Data. So this implies that we have to establish and implement methods to reach two major keystones. First, create fair linked open data, which is directly connected to the origin database and is interlinked to external repositories. And the second keystone, create research tools to make this data usable and findable by enabling third-party software like the Sparkling Unicorn Cubis plugin as we heard before, using this resource for further analysis. Starting with keystone 1, what have we done? So this is the transformation process from relational structures into RDF. And yeah, we accepted the challenge and we created our own workflow in this. Yeah, there is also some programs and some software where I can do that, but yeah, we had some special things to do, so we created our own. So first, we curate entries in the Semantic Research database, which are stored in a PostgreSQL database. Then we create database views from the original database tables via Cold Fusion and SQL. Then we export database views as CSV files, transform the CSV files with Python to RDF according to our ontology, import the RDF files with a Java application in an RDF for JTripple store, and link our data to the Linked Open Data Cloud, for instance, Pleiades and Wikidata. So the first step is to transform the whole CSV files, which you can see here in this picture. There are a lot of instance files or lookup tables and a lot of cross tables, which we have to transform according to our ontology. And our ontology represents a graph model of the original relational database, which includes vague relations, which is called, which you can see here in the little green dots where they're shown AMT. I will go in detail in the next slides. As I said before, the data contains strings with vague expressions. And we model this vagueness using a tool that is called Academic Meta Tool. We had introduced that, I think, 2 years ago in the Little Minion session, which is also tomorrow. If you want to join us, it would be cool. There were a lot of cool things which were shown there. How are these vague things and vague strings in the database? The vague relations are modeled as strings containing and or statements. So for instance, you have an information carrier 118, 117 that has the Kirnseite Rheinzabern and Kreawald. You also have an actor entity, so Potter Quietus, who works at the place Rheinzabern and Kreawald. And maybe you have an information carrier 118, 117 that is represented by 3 different pod forms, so 15/17 or 18 or 1831. So the question is how to model that in linked open data. So the first example is here. If the Potter Quietus has worked in Rheinzabern and Kreawald, this for us means that this is resulting in the degree of 1 here for Rheinzabern and also in the degree of 1 Kreawald, which works quite well because if you look at the Potter career, you can see that he first worked in Rheinzabern and after that in Kreawald, so it's both. So it's okay if he really worked in both places. And therefore, information carrier 118 and 117 has the Kirnseite Rheinzabern and Kreawald, which is also resulting in a degree of 1 for Rheinzabern. But here's the question: is that really an and or is it an or? So does it result in a degree of 0.5 for both of them? That's an interesting modeling question. Maybe you have some ideas about that. And the information carrier 118, 117 can be represented by the pod forms 18 or 15/17 or 18/31, which is now here resulting in a degree of 0.33 for 18 and all the other things because it's an or statement. Maybe we can model it like that. And all over that, the provenance information for the transformation process is stored using the BREF-O ontology. And to conclude this here, we just created for this small part of the Semantic Research database, nearly 8 million triples, more than 300,000 instances, and there are more than 185,000 information carriers, nearly 10,000 actors/porters. more than 38,000 discovery sites, some production centers, more than 100, and out of them we created some kiln regions using PostGIS.
2 minutes left.
Oh, so then I have to speed up. As a result, we have linked Open&FAIR, and we have to link it to the linked Open Data Cloud, using, for example, Open Annotation to link it to Pleiades, and we import it into Wikidata using Open Refine and Quick statements, as you may know, and then we have data into Wikidata and just do a bidirectional link. And just really short keystone 2. It's the Refred Dragon API, is the resource registry for data dragons. It's an online catalog, search API service for LLD resources, a resolve API service for LLD resources, and it have to provide a standardized data model according to the JSCORS standard by the VZG in Göttingen. And the interesting thing is that this should be done as a community work from the CAA SAG Data Dragon hosted by the RGZM, and there's nearly 1 alpha release which was published in early 2021. You can check out that on our GitHub page, and it's written in Java. And you have there different methods, as I said, LLD search and result service. And then you get a JSON result here, just one example based on JSCORS for Lion from the Getty AAT, also in an HTML representative view here. The same here if you just resolve one LLD resource, like here it's also one item from the Getty AAT, and we have also a short HTML view about that. So let's conclude. Making modern data dragons linked, open, usable, and fair, and creating easy to use allowed little minions have huge implication for archaeological research. Combining distributed online resources of completely different find groups, for instance, Amphoras and Terra Sigillata, offer entirely new research perspectives. Thank you. If you have any questions, just ask.
Thank you, Florian. So let's see if we get some questions in. There is just one question from the previous talk or a reply. Maybe if you want, you can use the time for, because I'm personally interested in the Wikidata importing of data, so maybe you can use the time to elaborate a little bit on that.
Yes, I will just go back with the slides. Yeah, so for that, we just thought that it will be interesting to not import all the data into Wikidata, but especially the find spots and production centers and the kiln regions into Wikidata, just to be part of the Linked Open Data Cloud. And we have done that as shown here using Open Refine, but you can also, yes, scripting, do a scripting by Python, because we just used Open Refine here to create some quick statements. And with that really cool tool, we just imported it into Wikidata. And the most important thing is that, yeah, here you can see the, yeah, we imported discoveries or discovery sites, the production centers in the kiln regions. And the most important thing for us were that we also set a bidirectional link into Wikidata, so that we have a bidirectional connection into Linked Open Data Cloud, because that is the thing that is mainly missing in the whole LLD world, and most of them are just unidirectional links. And yeah, and we just copied or imported some, yeah, not all the data, but yeah, the coordinates and something, so that we have Wikidata resources as well.
Thank you. Any other questions? Yeah, Keith is asking, So he would love to do some research queries that relate different dating evidences across Samyang data, coins, pots, and dates. And he is asking if that will be feasible someday.
Hopefully. I would be interested in that too. So,
so do you think it will be feasible with the system you're doing, or do you think it will be something like asking, querying different databases, or do you think it can all be done in Wikidata?
I think, yeah, there will be just a solution with distributed stores somewhere, and we have to focus on that. And yeah, so that we do that things not on a one project system somehow, but yeah, that we can do that with some kind of really complex infrastructure, just asking distributed databases from everywhere, and do that in some kind of different system, maybe like that.
Thank you very much. So I think we can then continue with the next talk. I myself, I'm going to hand over hosting of the session to Florian, and he will introduce our next talk.
So just give me 1 minute, and I have to change my slides. So
I can share the slides and then you can talk.
No,
okay, you're done.
So yeah, welcome everyone. So our next talk will be held by Sophie Schmidt with the title Roots to Linked Open Data, and she will present her first steps in the PhD. So yeah, have fun and go forward.
Thank you, Flo. So I just start my sharing my screen. Go to my presentation and present. I hope you can see everything now. So thank you very much for the invitation to present my first steps into the PhD. Yes, more or less like this. I want to present on my PhD database, and I want to discuss problems with you mostly. So some solutions I've got, but some other solutions maybe you might have. It's kind of funny because I just noticed Dominic Lucas is in this session as well, and he was the first person to introduce me to databases like something like 8 years ago. So hi, Dominic. I will now talk about what I'm going to do. So in my PhD, I focus on the 5th millennium BC in Brandenburg, which is the area around Berlin in Germany, for anyone who's not so familiar with the area. And there I will focus on the different ceramic traditions. So there's stroke ornamented ware culture, resin culture, Brześć-Kujawski, and the Mesolithic Friesack-Boberg group, to name just the most important ones. The archaeological aim of my PhD is to analyze the relations of these groups to each other, spatially, chronologically, and in terms of contact, and to take a look at their preferred settlement sites and subsistence strategies. This is a fascinating area because we are here in a contact zone between Neolithic people and Mesolithic people, and in the time after the first colonialization, if you want, of the linear band ceramics. So it's actually a lot still happening in the area. Now, after working in a more methodological and technical area for the last 5 years, I aim to practicing nice and clean open science and enabling reproducibility by scripting my statistical analyses and publishing the data in an open and fair way. And the best open data is linked open data. So yeah, that's why I'm here. My database has therefore a few technical points that need to be fulfilled. So it's supposed to be a relational database because I want to have the R in FAIR, the reusability, and archaeologists are not really using graph databases yet, as far as I can see. So it should be relational. It needs to handle spatial data and images very well because, well, that's what I need for my archaeological questions. For modeling requirements, I want to model it to standards of ceramic documentation because standards improve the reusability factor as well. I want to map to CRM because the interoperable and fair is something I aim at, and as far as I can see, CRM is at the moment the most widely used tool for that in the heritage studies area. And I want to create a database that will be easily transferable to RDF, because I think linked open data is in the end the future. So the structure and the modeling points of the database lead to one day being able to be fair and linked open data. The technical points will be like best fulfilled if I use a PostgreSQL database, and the modeling points will be the main part of my talk. I will start by giving a very short introduction to the ceramic documentation system I use and to CRM, which you probably all know. And then I'll put the model I created next to the system it's supposed to map to. This way I will highlight problems and possible solutions. In the end, I will shortly introduce the way the PostgreSQL database schema looks like to show my solution to the RDF-ability of the relational database that it is. And this is still a work in progress. And as I said, I would be delighted if you had critical comments and ideas how to improve my route to linked open data. Ceramic descriptions vary a lot from traditions to tradition, and also within these between specialists as well. This leads to difficulties in comparison between datasets. And though I realize that, of course, every dataset is collected with a specific aim in mind and therefore will vary, it would be great if there was some kind of standard which allows cross-collection comparisons. The NONEC, which translates to Northern Central European Ceramics, was initially developed by Doris Mischka in 2006, and since then has been continuously enhanced and further developed to include not just Neolithic ceramics, but also that of later periods. It has been used in quite a number of PhD databases so far, and so I think it's kind of becoming a standard. But as I said, it's still under development, and just a couple of months ago, Moritz Menninger assembled a new team to continue working on it. And as I had already started on working on understanding the system, I joined the group, and some thoughts I will present later on were developed within this setting. The aim of the NONEC is to have a systemic description that's so flexible that more or less any kind of ceramic vessel can be described by it. And I will only focus on the ceramic decoration part of the system for this talk, but it's also considering shape and tempering, all the other things that we usually think about. So the decoration is described by elements, patterns, and ornaments. An element consists of a type of decor, a technique with which it is created, and the orientation towards the rim. Patterns are then constructed by describing the spatial relations of elements to each other. More than one pattern at a certain place of the vessel will create an ornament. Now, CRM, as you probably all know, is the conceptual reference model of the International Council of Museums and aims at the interoperability of very diverse data sets by describing relations between classes. So it's a graph-based approach that lends itself well to RDF transformation. The version 7.1.1 was released in April this year, and so that's the one I use. To create my preliminary model, I used the recipes tool by Kainibis, with which you can create classes and connect them with properties, but only if these can be connected within the CRM rules. And this was very helpful for me to stay within these rules and not to start connecting classes that shouldn't be connected in the way CRM works. So if you want to try it, I can highly recommend it, but it's an ongoing bachelor's thesis, so I can't give you the code. It will be published, but if you're interested in it, just write an email to Kai. Now I want to start with a modeling description. In the working group I mentioned in the beginning, one change that was proposed to the NONEC system was to single out some primitives. And it has been discussed whether these primitives are the same thing as the elements in the system at the moment. But I think in the elements group in the NONEC system, there are at the moment 2 levels hidden. So I jumped upon Christian's bandwagon, whose ideas this was, and modeled the primitives separately. A primitive is the smallest non-separable part of a decoration, such as a dot or a dimple, and it has been created using a certain technique and tool. And you can see the modeling I created here with the CDOC theorem. Elements are now a combination of one kind of primitives with a type of alignment. So for example, a line, or it's just one single object. And the second point is the orientation towards the rim. So it's either horizontal or vertical. So on the short pictured here, you can see there's one row of dimple primitives made with finger imprints that's horizontal. And also there is one horizontal of one lip or bulge. Now trying to model the two elements in CDOC CRM, everything was fine, but for the orientation of the element. I used placement here as a superclass for orientation, but I'd be happy if any of them had a better idea. So I have got the element E25, which I said placement is horizontal, maybe not a good idea, but it has a type, it's a line, it's identified by identifiers. It's composed of the dimple that shows features of the fingerprint. Next, I want to model a pattern. So in the non-X system, an element can be repeated and show a certain spatial relation to another element to form a pattern. I had a look at what CDOC CRM offers for this, and I found the depicted classes and properties. As you can see, the number of my question marks rises. I've used P62 depicts to connect to the number of element repetitions and P53 and E53 to model the relationship between elements. A subproperty for the number of repetitions might be more sensible, as well as a custom designed subproperties for the relation between the elements to each other. I think you will see on the next slide why. Yeah. So if I try to model my model chart here, it kind of works, but it feels very clunky. So I've got one horizontal row of dimple primitives made with finger imprints, has the location on top of one horizontal lip. This is depicted by the pattern, and the pattern is composed of the horizontal lip and of the horizontal row of dimple primitives. And I added just, at the moment, it's not this important, but as a shortcut to when I need to model one element several times, I thought I would add the repetition by using just the number 1 and depicts. And also, of course, the pattern again has a label and identifier. Ornament is, as I said, created from patterns in a very similar way as patterns are from elements. Therefore, the relationships I modeled here work the same way as I just said for the patterns. Ornament is composed of pattern. Ornaments depicts the number of pattern repetitions and the placement of the patterns to each other. The pattern has a placement in relation to another pattern. So I'm not really going into details here again. It's the same thing again, just on a higher level. So my model so far has been made of, if you want, pure CDOC CRM, but it seems in parts not to be the perfect solution. So I have been dreading it a bit, but I think I will have to create my own ontology and create my own subproperties for repetitions and for spatial relations of elements and patterns.
Two more minutes.
Woo! Okay, great. So the next step, and to change the topic a bit, is how I want to create my PostgreSQL database scheme, which will allow for easy transformation in RDF. First step was to define lookup tables for all classes and properties, and a second step, create cross tables that connect these to each other in the RDF logic of subject, property, object. This seems quite straightforward until one remembers the way patterns and ornaments are modeled. So here I created a special chain table where rows can be linked to each other. The number of positions inside the chain determines how the rows are linked. So in the completely arbitrary example here, I can see that the element with the ID 10 is repeated twice, is on the left-hand side of element 12, which is repeated once and is in the pattern A100 in the chain position 1. And it's the same element as element 1 here on the left-hand side of element ID 21, repeated 3 times in the chain position of 2. So this way I can model a really large pattern if I want. This is a short overview of how the RER diagram of this model looks at the moment. So it's, sorry, it's in German, but you can see all the E numbers for the classes and the CT tables for the cross tables, where 2 IDs are linked by a property ID. To return to the topic of linked open data, I will integrate open resources in my database. Chronology and periodo offer periods and cultures to which I can link, and geonames will be used for sites. A small project funded by the Wikimedia Foundation in Germany within the fellowship Free Knowledge enabled me to meddle a little bit with Wikidata and design a few classes needed for the description of prehistoric ceramics. So I plan to integrate at least some of the information I gather from my PhD in Wikidata as well, like sites of found sherds and basic primitives and elements of decoration. To conclude, I would like to give special thanks to the people who took time to discuss my project with me, like Florian, Jan Wieners, Kai Niebes, Christian Beeth, and Moritz Menninger. And thank you for your attention. I'm looking forward to your questions and comments and how to improve my route to linked open data.
Yeah, thank you, Sophie. So just in time.
Perfect.
So yeah, we have one question I can see. I'll just read it out from Martina. I'm aware of a project to describe seals in a graph, and they have similar issues with modeling positions of image elements. So yeah, Martina.
I would check that out for sure.
And Martina also give a hint to the icon class. Yeah.
Okay.
So, and then there is another one. I have to make it a bit bigger. By Barbara Löbel. And she wrote the question, Sophie, how do you balance the level of detail in your database to avoid to be too complex? Do you believe it is more important to record every detail to the level of primitives as you define them, or to adjust the level of detail to the research questions that you are focusing on your current project?
That's a very kind question of telling me not to do too much. Yeah, thanks. I think the modeling of the pattern is actually not that horrible much, really. I will just, I mean, the patterns and the ornamentation will repeat in my database. So I will just model these and once, and then I've got this lookup table and can just add the pattern ID to the sherds I actually look at. So it's quite detailed, I think so, yes, but I think it will enable a better statistical analysis as well later on when I want to analyze the different kind of elements and decorations.
Okay, thanks. And there is another question from Anne Klamt. And she asks if there is a research question into the details of the patterns. So there is the line to the prehistoric reality. I'm struggling on the same issue.
So the question is whether the level of detail of the decoration is really that important. That's
if that is part of your research question.
It's part of if you want, research question of another small of this, maybe this working group that started on working on making NONEC a little bit like continue working on NONEC. So I think actually it's this, the question of what's a primitive and what's like the smallest unit of decoration is actually quite interesting and it's archaeologically very relevant. Like is And this is something that probably needs to be decided for every culture you're looking at by itself. So what is the relevant smallest unit that has been used? I think that's something I will discover when I really start to look at all my data, and it's easier, I think, to generalize later on once I've done a detailed deconstruction of the patterns than to later on make smaller subgroups of the things I'm looking at. Does it make any sense?
Okay, so and just one last thing, maybe with a short answer. Joe Rowe says, thanks for the interesting talk, Sophie. The Wikidata extension sounds very exciting. Do you plan to use the SciDoc ontology for this also, or a different model?
I'm not trying to use NONEC for the Wikidata stuff because I think it's not interesting for the Wikidata community to go into this kind of level of detail. It's more for the archaeological research interesting, but I think using the primitives just, as to show people a shirt can be decorated by a triangle, whatever, is useful. The small Wikidata project I'm doing is done with volunteer archaeologists who want to use Wikidata together with me to create something like a lookup area, like where you can search for shirts and pictures of shirts. And they are not in that detail familiar with every small possible archaeological decoration system. So I'm using very easy describable forms. So a point, a triangle, whatever. So they can search for these patterns and find shirts that may look similar to the one they just found and want to have a look what it may date like.
Okay, so thank you, Sophie. There are a couple of more questions and things which are going on in the chat. Maybe you can have a look at that and answer it there. And as you have seen, I also helped Sophie a bit out of these things, but I'm not the real expert on SciDoc CRM, so maybe the people here, and I know a lot of them, they are here from the SciDoc CRM world, may contact also Sophie directly. And
yes, give
her some hints. That will be really cool. So, okay, thank you, Sophie. And we will go over to the next presentation. But just try to introduce the next speaker. And hopefully you can So hopefully you can see it. So our next speaker will be Anton Coetzee. And yeah, just go on, and I'm excited. Thank you.
Hi, thank you, Florian. Let me just get my screen shared here. I'm looking for that. There we go. Okay, so Metse Macholacholo, oh, excuse me, basically is a project. In our official title, I suppose, is a multimodal landscape archive of African urbanisms. Metse Macholacholo means ancient towns or abandoned places in Setswana. So we're covering the region we see here in Southern Africa. And looking at late 18th to early 20th century Tswana urban spaces as a significant instance of pre-colonial African urbanism. And we're producing a digital archive of interlinked materials, effectively allowing for a deep exploration of forms and modes of Tswana urbanization and urbanisms through time. We thought it's appropriate in the session being titled Sunt Dracones, because we very much are in unknown territory here. We really are the first to do this sort of thing within an African context. So what are our aims? So firstly, to develop a spatially organized archival repository geared towards research, and experiment with different archival and presentation formats and metadata schemas. We're exploring the relevance of key archival principles for materials not traditionally considered archival, at least not within the kind of archival community working here in Southern Africa. And looking at the usefulness of using space and landscape as a fundamental principle in archive design. And ultimately producing a multimedia platform for both teaching and learning, effectively in parallel with our archive. So to highlight this, our project is ambitious. There's a lack of data and a lack of work done with existing data relevant to a pre-colonial context. So in a sense, we have to create these data dragons from scratch and simultaneously be finding ways to tame them. So the sort of data we're working with is widely varied, both in form and spatially. It spans many archives and collections across Southern Africa and across the world. And little of that has actually been digitized at this point. So we have geospatial materials, shapefiles, geotiffs, historic material which has been georeferenced. We have text, plans and maps from reports and so on. Photographs, historic photographs from excavations, current stuff, things that have been born digital, things that have been scanned, books, manuscripts, artworks, 3D models, point clouds, and then finally, but I'm sure I've forgotten other things, climate data, both historic and derived from historic data. So it's quite a large collection there. So it's a mix of primary material, born digital, and derived works as well. Okay, our philosophies. So this project is aligned with many of the core principles, I suppose, of this session, both findability, interoperability, linking, and so on. So our approach to FAIR and accessibility is that, firstly, this archive is not explicitly and exclusively for academics and researchers. It's to some extent for laypersons, but also for students of varying levels, and therefore suggests certain various forms of exposure, exploration, presentation, but all wrapped in high levels of usability. So we're particularly interested in the relationships between objects and actors and how these are located both spatially and temporally. So that speaks to the concern for creating connections between data sets in order to form this web of data that is explorable. And we're also attempting to challenge traditional principles of archiving and much of their reliance, at least in traditional archiving, a very rigid hierarchical organization. And finally, on this point, our members cover a very wide range of disciplines. We have people from archaeology, geoinformatics, art history, digital art, history, climatology, rock art, heritage, pedagogy. So we bring a myriad of different lenses to bear on this material and our interactions with it. And also our group comprises a range of levels of specialism and experience. We range from students to professors. Then in the longer, and then so I suppose as an extension to that, in the longer term, we want this platform to be open to a wider audience, not necessarily a popular audience, but as we said earlier on, both students and also of varying levels, but also an interested and informed public. And then we want this archive to be something that is produced as well as consumed by the users of this platform through interaction, curation, annotation, and sharing. Basically, the archive is a product for its users and as a product of its users. So how are we organizing things? So we really first thought of how we wanted to use the available technologies to make something accessible. Not just, as we mentioned before, not just lay people, but researchers and students who are not necessarily embedded or versed in this field. And so we thought of the notion of an exploratory interface rather than a searchable interface. It is searchable too. That's all well, as you'll see in the demonstration just now, but primarily exploration. And to that end, the material is knit together using the concept of spatial relationships. And we're also foregrounding relationships, both spatial and other natures, between objects and other objects, objects and places, objects and actors. And this offers quite a fine-grained entry point into material and concepts. And then, to borrow a phrase from one of our collaborators, Giuseppe Salemi at the University of Padua, we're working with data and visualizing them from a macro to a micro scale. That is, from a landscape scale down through site scale, right down to object or artifact scale. And then basically through this, the idea of digitally and spatially reconvening material from a site, effectively material from a site that is in collections and archives, and bringing it back together effectively in the site where it came from. And in this, also we'll talk a bit more about this, is aligning our alignment with the SciDoc CRM ontologies for organization of that. So yeah, we started thinking about those relationships, and what effectively resulted in us ending up with SciDoc is, so on the one hand, we were approaching these from an art historical point of view, looking at the lives and biographies of objects and their individual agencies, kind of from a Latourian point of view here. But then on the other hand, exploring their spatial and spatiotemporal links and how these might be visualized and leveraged for both research and teaching purposes. And these approaches kind of challenge the idea of stable and authoritative sources and encourage critical engagement, an understanding of things in context, and hopefully enable the construction of narratives, curations, and story maps. Apologies, I'm not sure what that pinging is coming from. Okay. And then fundamentally, we're internally aligned with the SciDoc CRM ontologies, and we're beginning to formalize those alignments by explicitly referencing CRM entities and relationships internally. Although, as we've all seen, is implementing SciDoc CRM is very much a non-trivial problem. So this is just an illustration of some connections and the notion of relocating within a landscape. So the key object here is the small stone. It's used for polishing Zulu Izikoko head rings. This was found in a pot dimple in the floor of a hut, as we see. And following the connections in one direction takes us to an image of the pot dimple, a plan of the hut floor with the location of the pot dimple, the huts showing that hut, the hut group within the overall site, the site within the landscape. Then in the other direction, we look back to an image of a person wearing that head ring, which is not in this collection. It did not come from the site. It's an external resource. And then to a collection of these head rings in a museum collection. So we are looking backwards at more abstract concepts and types of objects, and objects which may not have come from the site, be resident elsewhere, and the kind of thing that suits to being linked to in an external database or collection. So given that our initial abstract for this conference was over a year ago, we now have a slightly more functional prototype to demonstrate. It's a relatively simple architecture: Python, GeoDjango, Spatialite, and then using open layers on the client side for the mapping. The platform's still experimental, available only to members of our project for the purposes of development. But we form a diverse group that is kind of a microcosm of the community of users we would like to ultimately reach here. So the entry point here is organization by site. Much of the material I'll be showing here is in fact from a site called Umkunglovu, not directly related to our target material, but one of our collaborators, the 500-year archive at the University of Cape Town, is focusing on the site, and so some of the material has already been digitized. This was the royal capital of Zulu King Dingaan, and it's quite a rich site. So here we see some site details. In the first group we say as relationships, you see we're absolutely foregrounding the SciDoc relationships here. So these were all effectively built, constructed on ingestion. And the second group is spatial relationships, which are derived automatically on ingestion of objects, either through extracting boundaries or centroids of geospatial archives or explicit entry of locations. We also have the option at this point of simple spatiotemporal indices, although we haven't tested that yet. Detail of an object. This is the polishing stone showing metadata and further relationships. Please
2 minutes left.
Thanks. Another object, series of shape files. A spatial search, another entry point into the archive. So this shows all the objects in a particular area. And their bounding boxes or individual locations. And then this is now the objects earlier on relating to a collection showing effectively the notion of scale. We have an historic map. We have some more modern site diagrams, which have all been georeferenced. And we can go down from landscape scale to site using a historic map, a more modern site map, all the way down to individual artifact level and its location here, but all in context, all drawing from diverse sources. Then story maps being an alternative entry point, ArcGIS story maps using material from the archive and linking into the archive as well. And then to conclude, sorry, running out of time. Linked data should work both ways. We need to be both suppliers and consumers, but we have little to hook into, given the sparsity of material and databases linked with our geographic, cultural, and temporal fields. We're still actively trying to locate our position within the linked data landscape. And as a consumer, we don't have the luxury of pre-existing bodies of data for our region. We're starting from scratch. And as a producer, we're working on it. Secondly, finding an entry point into the linked data ecosystem is very hard. We see initiatives such as Pelagios and the World Historic Gazetteer or the Getty Vocabularies and so on. We see that, well, there's little here that's of value to us or represents the materials or regions we're working with. So then, okay, it's up to us to contribute, but how? Thirdly, other projects with which we're collaborating have their own philosophies and backgrounds. Traditional archival practices that involve static, highly structured, and hierarchized organizational schemas. It makes for very interesting challenges attempting to align metadata and archive interoperability. And finally, awareness and inertia. In discussions we've had locally in South Africa, there's little awareness and even less understanding of the value of these more progressive and domain-aligned metadata schemas, such as SciDoc and linked data. And the emphasis to a large extent is still just on getting the job of digitization done, invariably squishing their data into generic standards such as Dublin Core or EAD, which no doubt is going to end up resulting in far more digital collections being marooned or in fact unfindable. Okay, sorry for rushing that last bit. Thank you. Thank you for listening.
Thank you for your presentation. So I just have to look if there are any questions in the chat. Right now, not. So if you have any, please write it shortly down. We can use the last couple of 4 minutes to answer them. Would be cool. If there are no questions, we could go on. Just because we have this really tough schedules. It would be really cool to save every minute we can. So
great.
No further question, but yeah. So great talk, and hopefully
thank you.
Next year we will have some more interesting results. But yeah, I really like it.
Absolutely. Thank you.
There is one from Keith May. How widely would you look for parallel data across Africa?
Well, as far as the actual origins of the data, I suppose the fact is, this is not really my specialty. It's one of my colleagues, Dr. Merlot. I'm not sure if she's able to speak here, but basically, the initial project is basically looking at Tswana, the Tswana settlements covering the regions from kind of southeastern Botswana into northwestern South Africa. So that's the initial focus, and that was what was presented to our funders. Then we have been looking as for test data, we've been looking at some of the Zulu material in Natal. And I suppose the fact is, in the long term, if we can get funding to carry this on, because we're effectively approaching the last year of this this branch of funding, the sky really is the limit. We will actively look at other stuff around Africa, but most probably it'll be around Southern Africa, South Africa, Botswana, Lesotho, I suppose that region generally.
There is one more comment from Anne Klamt. She says, thanks for the presentation. I think this is really Grundlagenforschung, so yeah, it's primary research somehow, and hopefully there will be funding, she said.
Yeah,
so,
yeah. We are actively pursuing some other routes, so yeah, hopefully.
As always, so
yeah.
Funding is always a good thing.
Indeed.
Okay. And just Keith May answered, thanks, Anton. Okay, let's hope COVID allows that soon. So
agreed, absolutely.
Okay, so I cannot see any further questions, so we can just go on.
Yeah, thank you.
And I will just share my screen to introduce the next speaker. So hopefully you can see my screen in full screen. Our next speaker will be Dominic Lucas. And yeah, I hope you are ready. And you have 15 minutes, so just go ahead.
Wonderful, thanks so much. I hope the slideshow is visible.
Perfect.
Okay. I want to talk today. No, first off, I want to say hi to Sophie. It's great to see you again. I want to talk today about the ongoing development of the Living Archive of Çatalhöyük, which is intended for researchers as well as non-experts to examine research results at Çatalhöyük by using common, widely used definitions or ontologies, of course, and by allowing new data to be produced from within the existing database. Çatalhöyük, a 9,000-year-old tell site in central Turkey, is considered amongst the very earliest dense settlements discovered to date. The site opens a window onto the transition from hunter-gathering to sedentary farming societies. The site has had two major phases of excavation, beginning with James Mallett's project in the first half of the 1960s. Almost immediately, the site gained international significance for its high level of preservation, distinctive layout of streetless clusters of houses, and a large assemblage of features representing the symbolic world of its inhabitants. In 1993, Ian Hodder began the 25-year Çatalhöyük research project. During the over 2 decades of archaeological fieldwork, research has led to the accumulation of a dense record of multidisciplinary information, full-text taxonomically organized descriptions, specialized databases, recording a range of scientific treatments of the collected material, images, and geospatial information. As in other archaeological research projects at Çatalhöyük, data have been stored and processed in ways that reflect the initial strategies about how to conduct research established when the project was originally conceived. In response to the intricate relation of scientific knowledge and the context of its production, research at Çatalhöyük followed a reflexive process whereby information about the project itself is incorporated into the database archive in order to allow for reinterpretation, understanding, and critique. An important aspect of this approach has been the decision to document the documentation process, that is, to provide an additional layer of information specifying how data have been gathered and indicating the questions that have been asked. Reflexive data include excavation sketches, video recordings containing information on the context of archaeological practice, and an intrasite GIS, which was designed with the intention of promoting a series of digital practices to enhance the reflexive ethics on site. Although it might appear contradictory at first, the idea to add a whole new level of data to an already complex archive, the additional layer of information should be understood as a layer of transparency to render the making of knowledge increasingly accessible. Before going into detail on our approach, making, of course, use of ontologies to integrate our data, it is necessary to underscore the issues arising from interdisciplinarity in concert with the additional layer of reflexivity that is present in our example. In order to make the heterogeneous sets of data generated on site available in a unified environment, the ontologies applied during the process need to be homogenized, which is achieved by developing a specific site ontology. A certain level of transparency can be achieved by making the modalities of data modeling and the encoding of data available during the process of information retrieval. As an example, I want to mention the work done with a foundational model of anatomy, which is being used to map the data from the Human Remains Laboratory at S02Hic. In studying existing classifications of anatomy, the developers of the FMA realized that theories are conspicuous by their absence in the biomedical domain. The cell theory, advanced in the 1830s, seems to be the only one that has been proposed in the field of anatomy. None of the time-honored textbooks or sources declares a theory for sorting into type cellular and acellular entities, which together make up the anatomy of the human body. In lacking an existing classification theory, they implement the ontology using definitions consistent with Aristotle. It is important to note that the absence of the previous theoretical approach at this point renders the ontology not only an artifact to be used in the processes of knowledge engineering, but the model needs to be conceived as a theory in itself. In contrast, the ontology, which of course needs no introduction here, the CDOC-CRM, as discussed in a paper from 2018 by myself and colleagues, we have attempted to model as much data following the CRM as possible. Beyond the structural conflicts of the original data model with the conceptualization of the CRM, we also need to look at the underlying assumptions that might have import on the practice of integration of different ontologies. The principles of defining classes and properties in the CRM are based on the idea that everything is based on events. This idea, again, relates to the philosophy of Donald Davidson, while we find a similar approach in phenomenological schools of philosophy, which have become increasingly popular, of course, in archaeology in the last years following the material or the ontological turn. What I want to point out in the context of this presentation are the purely theoretical implications that the integration of ontologies brings along. Ontologies are conceived based on specific underlying theories, like Davidson's or the theory then created by the FMA, which brings metaphysical issues back into the discussion, although these have mostly been evacuated from the discourse, as ontologies and computer science are believed to simply structure knowledge as it has come upon us after the fact of extraction from sight. The reference here is, of course, Quine's famous posit of the ontological commitment. As is discussed by the authors of the foundational model of anatomy, ontologies are not only artifacts to be used in the processes of knowledge engineering, but they are in fact theories in themselves, which then need to be discussed beyond their mere usage. These theories are, of course, not expressed in the ways of classical philosophical texts, but they reside within the structure of the ontology itself. This is an example, in fact, from our paper in 2018, where we tried to model the S02Hic approach to units and features, and the ways how, in fact, it was possible to mostly map the classes to each other. After a set of iterations, beginning with a preliminary prototype in 2015 by Karl Grossner and Claudia Engel, and a second prototype in 2017, the Living Archive has now been developed, or is on the verge of being finalized, to provide access to the data gathered at S02Hic while responding to the requirements indicated above. In order to make the genealogy of interpretation transparent, the web application makes use of semantic modeling. The data sets originally stored in distributed archive are now aggregated following the principles of linked open data. And at this point, we also have to thank the Getty Foundation for their generous funding of this last phase of the project. On a technical level, this has been achieved by transforming the different traditional databases into a core semantic database, where stored data are enriched with the information concerning the meaning and role that the data have within the research project. The semantic data are stored in RDF, organized via an OWL ontology mapped to a set of relevant domain ontologies, like, in fact, the CRM, the FMA, and others. Hereby reflecting the multidisciplinary background of research at S02Hic. As it has become increasingly common, access to the data is provided via a web application, but also a REST API. This is the actual the present stack at present, and we had some changes here, changing the triple store multiple ways, now making use of mark logic. This is a preview. This is the view of our little application, which is what we will see in a second. The central core of the navigation is the ontology view, which is based on the implementation of WebVowel, which allows for or which attempts to allow for an intuitive use of and navigation of the data. Having learned from the necessities to discuss problems in using the original database structure with researchers on site, and also from the development of websites all over the World Wide Web in the last decades, we streamlined the process of interaction with the data, limiting the options that tend to drown the experience more often than not. Ontologies are not in themselves easier to understand as relational database models, and therefore navigation is thought as moving along the knowledge graph. And this is what we see here, that one can select a class and then move along the arrows and the bubbles, which of course are the representations of the classes. Here we see the interrelation with the FMA and the classes again around, which cluster around the unit, of course, which is the core entity from single context archaeology. Here we see the relationship with the CRM Archeo extension class A8 stratigraphic unit. And now we're going to combine the classes, and that is the principal feature of how information is selected. One combines those classes of interest, and then in the background, the system reconnects those classes as much as possible and along the OWL and RDF principles. And then one can get into the aggregation of the data, again, based on the data that is retrieved. Here we see the individuals, so the human remains, and we're filtering down to a subset of individuals along the chronological order level, south level S here, and those are the female individuals. We can, of course, and I mean, those are rather standard ways of interacting with data, see that in a GIS view. Then we can select a specific unit, a specific entity, and then we get into the repository view, which then shows us the details that are connected to this entity. And on the map, we see the skeleton in situ. And we have a little stratigraphy module that, of course, is not on the level of what Keith May presented before. And yeah, and then we can see the different information here. So there is the access to the photos, or if there's a video recording or a diary entry, those are accessible as well. Here we go. Just to see the possibilities of further interacting with the data, we can select again and then get into an 1 second. Yes, we can select this. We see that. And move into that to see the contextual information around the spaces in which the unit is embedded. And then we can, of course, also do exportation of the data. And in that case, we have the tabular view, which is a little bit extended because we do not see the column of the bones that make that table quite large. And here we can export that as a CSV, of course. And one of the most interesting aspects, as we think, and one of the core ideas that we have, is now the question of what makes the archive living instead of any other archive. And this is the idea of, in fact, modifying the data, interacting with the data further, and adding information to it. The question here starts by simply trying to integrate data that has not been integrated with the archive during the time of the project. There have been, of course, researchers involved with the project whose data has not always come back to the source. So we attempt to further a collaborative approach and to enable researchers to, in the future, in the next years, to subsequently add information to it. This is achieved by this feature, the custom property, so one can create new classes, additional
minutes
classes.
left.
Yes, I'm hopefully getting there. One can add information based on these custom properties, extend the knowledge graph in that respect. And so there's the option to show this publicly. This means that other researchers that are connected with the system can then also use these extensions, and in this way a collaborative process of further developing the system is enabled. Here we can now add the data, and it should have streamlined the video a little bit shorter. And the last point that is necessary to be seen here is now that this property shows up if it's public and if someone subscribed to it in the ontology view. To come to the results, the question, of course, is the long-term accessibility of data. So either we are in the aspect of the archive for open access and of all the data. The living question is that there's no cutoff date, and we plan and we intend to dynamically ingest further data also from external sources, as data concerning from Chattahoochee can be found all over the web. And the linkability is achieved by using ontologies, linked open data. I'm not sure if we're at sphere 7. At the moment, I think we're around sphere 5 maybe. And the integration of Chattahoochee data already out there, I mentioned that. So here's the link. At the moment, this version that you have seen is not online yet. We're in a phase of testing with the members of the Chattahoochee Research Project, but you can already visit this site, maybe fill in a contact form, and we will keep you posted. Thanks to the entire project, of course. This is the list of people directly involved with it. And we just want to mention as a last thing, ontology is understood as a theory which is unique to the research project, as well as developed in a collaborative effort. The Living Archive approach therefore attempts to make the process of original development visible, as well as habilitate the integration of further information, as well as interpretation within the application. Thank you very much.
Thank you for this very interesting talk and this really, really cool application. If I look at the questions, there's not really a question, there's a remark, because Gerald Hiebel just wrote, thanks very much for the presentation, very cool work to show what can be done with semantic data in the background. Good to see you again. So yeah, you can just say the same. And I think for me, you can see here what you can really do with this normally technical and just conceptual stuff we're all doing. So looking forward for the next things you will do. It looks really great. Are there any more questions? So please type it in the chat. Would be cool. One more from Keith May. He wrote, great work, Dominic. Can I ask a similar question? If it is not too detailed about how I would best search for items from Chattahoochee, or is it pronounced, I don't know, that have been radiocarbon dated?
So I'm not sure if the question points to within our application now, or if that is related to the general question of how to get to these items. So the idea is that one would, of course, try to move along the ontology view and see in how far this can be connected. One can, as I showed, I think at a certain point, there was the question of the anatomical entity that one could search in the search box. So you would try to search for radiocarbon date or dating, and then you would end up in the cloud of bubbles around dating where you would find that, and then you connect it to whatever other aspect you would have. So like unit is of course always a good merger because that links to most of the data in the system.
Okay.
I'm not sure if this answers your question.
Keith, you may unmute yourself if you want to say if that was the answer you expected or not. Or write in the chat. He just wrote good answer, thanks. Sorry, it was too detailed. Yeah.
Sorry.
Okay. So another one from Thomas Huet, a posteriori, the computer languages used for the app, for instance, Python, were the most appropriate ones. Yeah.
So we actually didn't use Python. What we used is the classic PHP stack. And I have to say, I tend to say yes. There were some issues with speed concerning retrieving data from the triple store and reworking it in the background to make it accessible in a intuitive way in the aggregate view. Because the amount of data is quite extensive, as I think I have mentioned. But there are some tweaks that one can do with falling back onto C++ code, and we're actually working on that to speed up the process. But yes, I'm actually very, very happy with using PHP in the Symfony framework.
Okay, thank you. Any more questions? I cannot see anyone. So, okay. Keith also asks for the link for the living archive into the chat. Can you just add it? That would be cool.
Yes, I will do that.
Perfect. And so, yeah, then we will move on to our next talk. I will just share my slides again. And our next talk, I hope you can see the slide here, will be a video presentation, and it's on linked open data vocabularies and recognizing intellectual contributions via ORCID. And Ethan Gruber is here, and I think if you have any questions afterwards, you can just ask and Ethan may answer them. So for the technical guys, maybe you can just play the video and we will see. I think it's 11 minutes long, so we have a lot of this time to discuss after that.
Currently funded by the National Endowment for the Humanities and based at the University of Virginia, the Karameikos.org project, begun in 2013, aims to define the intellectual concepts of ancient Greek pottery, following the methodologies of linked open data. Under the supervision of the project directors, including myself, Tyler Joe Smith, and my colleagues, Renee Gondik and Ethan Gruber, current and former graduate and undergraduate students at the University of Virginia have worked to research, disambiguate, and define concepts relevant to Athenian figure-decorated pottery. External project collaborators are providing translations in German and Greek, and we have plans to expand this aspect to other languages. We note, however, that prominent archaeology membership organizations based in the United States, including the Archaeological Institute of America and the Society for American Archaeology, are now recommending that departments and universities should evolve their positions on the recognition of the intellectual effort involved in digital research and publication with respect to tenure and promotion and overall research productivity. It is clear that computation methodologies in scholarship and dissemination are increasingly in the mainstream in archaeology as a whole, and no longer a niche with certain institutions. Digital tools are inseparable from analog ones in cataloging and analyzing information and publishing new knowledge. In order to remain apace of these changes, it is also incumbent upon digital publishers to alter their workflows so that the scholarly profile of an academic can be populated and each contributor recognized for their work. Indeed, this is particularly important for the often neglected student participants looking to strengthen their CVs and to gain professional experience. In this paper, we are showcasing the recent progress made by the students who have been working on the Keramikis.org project. In this area, by formalizing their contributions to the project through current standards for scholarly communication using ORCID IDs, an issue we will return to later in this presentation. The concepts used by our project have been extracted from the Beasley Archive Pottery Database at Oxford University and include terms familiar to any student or scholar of ancient ceramics. These include production place, shape, style, technique, and artist. The vase on the left in the collection of the University of Virginia can be used to demonstrate these concepts. So the production place is Apulia in South Italy, the shape an oinakoi, the style is classical, the technique red figure, and the artist is unknown, and it is an unattributed vessel. However, for Keramikis, the major focus of student scholarly labor thus far has been in researching and creating definitions or biographies for major Athenian black figure and red figure artists, including both potters and painters. And this will be the focus of the rest of this presentation. Given the very large number of artists, by which we mean both named artists known from inscriptions and those created by modern scholars, listed in the Beasley Archive database, it's about 1,000 names, we realize the importance of narrowing the list to a more manageable size and one that would be representative of the more familiar names and most famous artists. In order to do this, one of our students, Caroline Stratus, compiled a list of about 200 painters using John Boardman's 3 handbooks on Athenian vases. This, I add, was only the starting point of this work, and we know that this list will grow and eventually reflect the entire corpus of artistic personalities. And now I turn it over to Abigail Bradford, who will discuss the work that was completed by the students, including herself, on this project.
Thank you, Dr. Smith. My name is Abigail Bradford. I am one of the graduate students here at the University of Virginia. Our team of students is made up of 3 graduate students in Mediterranean archaeology, 2 former archaeology majors, and 1 current undergraduate work study student. Our primary role with Keramikis has been writing the entries for vase shapes, techniques, and artist biographies. There are luckily a lot of really great sources out there for us to utilize, some of which Dr. Smith just mentioned. And so our definitions have ended up being a combination of descriptions given by very established vase scholars, including websites of museums like the Getty and the British Museum. Those have been particularly helpful. In terms of the division of labor, the way that we have worked has changed as more students have joined Keramikis. I joined the team in 2018. There were originally only 2 graduate students, so myself and Naji Olia. We began by writing definitions for shapes, and we divided the definition writing in half. This is where we originally had the idea to give credit to each person's work individually. So Naji and I were writing definitions individually. We were double checking each other's work, but the writing process was largely independent. We quickly realized this was too much work for just 2 students. And as time went on, more students joined our team, and the definition writing process became more collaborative. So for artist biographies, which is the focus of our talk today, we ended up understanding that it was a much larger undertaking than writing shape definitions. And so we formed teams within our cohort and began co-writing definitions together. And these teams would divide the work further depending on how we prefer to work. So for instance, I was partnered with Delaney Mitchell, and we split our definitions in half. So we would do independent research on our own, write preliminary definitions, and before we pass them on to the other team to review, we would review each other's work and aid in filling in gaps, smoothing out writing, and checking information. Each team would then proofread the other team's definitions, and then we would pass them on to Drs. Gondek and Smith for final review. When we first began writing definitions, we had originally envisioned that the student who wrote each entry would be credited as the sole author. As time went on, however, we realized that there was rarely a single author to any one definition, and that someone's original definition changed significantly as it was checked by other students and by Drs. Gondek and Smith. So I've taken here a screenshot of one of the spreadsheets that we worked in. So you can see we have an initial contributor, who I guess we could call the original author of each definition. But then as we began to review, proofread, fact check these definitions, we put our initials in the edited column on the far right. And as you can see, just about all of us proofread a definition before it was passed on for final revisions. And so we ended up deciding that students should be credited not only for the definitions that they took the lead on, but also the definitions that they proofread, since sometimes there was as much work involved in editing as there was in writing. So for instance, on my ORCID profile, which Dr. Gondek will show in just a moment, I am credited with far more definitions than I wrote myself, since we are giving credit to everyone who contributed to each definition. There's a certain amount of relief in not being credited as the sole author of any one definition. The Karameikis will, of course, be available for everyone to see online, and we're hoping it will be utilized by experts in the field of vase painting. And so there's a certain peace of mind as a student that there are other eyes on the definitions before they're published publicly, and that they are vetted by Drs. Gondek and Smith. So if an error does slip by in the editing process, mistakes won't be credited necessarily with any one individual student. And perhaps more importantly, we're all being given credit for the definitions we help produce, which is much different than simply having our names listed on a website. So I can link my ORCID profile on applications, and I have already done this, and physically show how much text I've helped produce for this project, which I think is a really unique part of Karameikis. I'd like to pass it on now to Dr. Gondek, who will talk about how we standardize definitions and also the process of uploading the information both to ORCID and to the Karameikis website.
Great, thanks, Abigail. So after considerable research, writing, and editing on the part of the students, the project directors, Tyler Joe Smith and myself, received the completed definitions and began the task of editing, adding, and reformatting. While the definitions were good on their own, they were not standardized, and it took a considerable amount of time to create templates. This was especially true for the artist biographies. A template was necessary for these since each biography needed to reflect the same type of data, and some biographies even cross-reference with each other, so standardization was essential. Of course, this template would have been useful for the students, but it's important to stress how organically this template came about. Indeed, we would edit a few entries in the Google Docs, as you can see on your screen there, realize something was missing or the wording was inconsistent, and then go back to re-edit what we had thought was already completed. It wasn't really until we had gone through a couple dozen painters ourselves when we were finally happy with what we had created. In order to help us fashion these definitions for the painters, especially, we utilize a variety of resources. Some of these included reference books like Beasley's Attic Black Figure Vase Painters and Attic Red Figure Vase Painters, published excavation data like those from the Athenian Agora, books concerning Greek vase painting like Boardman's handbooks referenced earlier, Martin Robertson's The Art of Vase Painting in Classical Athens, and R.M. Cook's Greek Painted Pottery. And finally, the online database for Greek vase painting known as the Beasley Archive Pottery Database. These materials, we were looking to understand several pieces of information: the date of activity for the painter, the origin of the painter's name, the shapes the painter often decorated, the subjects the artist often painted, and the fine spots of pottery associated with the painter. Once definitions were considered complete, they were uploaded as spreadsheets with the names of all the authors and editors. As mentioned before, since many individuals contributed to the creation of these definitions, all were given credit with their ORCID IDs. And here you can see on Karamikis.org's page displaying all potential authors of Karamikis materials. It includes their name, affiliation, and ORCID ID. If we click on the author's name, like Abigail Bradford, we can see a list of items Abigail has either authored or contributed to authoring. The date that coincides with each term, however, is not the date associated with its creation. It's simply when the informational spreadsheet was uploaded to the website. As we all know, it is becoming increasingly common to generate DOIs for scientific data sets within institutional or external commercial or non-commercial repositories, like Figshare or Zenodo. It is less common practice for humanities data. We hope that Karamikis's model for formalizing contributions to the Cultural Heritage LOD Cloud might influence other digital humanities projects to undertake similar steps in making the labor of students and other contributors more visible through DOI and ORCID integration. Thank you.
Okay, so that it seems to be that the video recording ended with the presentation. So are there any questions? I just saw that Ethan wrote some more links into the chat with some more technical background. Yeah, even though you want to say something about that, just some short words. If yes, just unmute yourself.
Yeah, I'd be happy to talk about any of the sort of technical background or anything like that, if anybody has questions. Or just in general, the all of the IDs created in Karamikis are connected using the provenance ontology from the W3C. So there's a chain of activity events for each Karamikis ID, which links those IDs to a source spreadsheet. Usually, most of this data work by students is done in spreadsheets and then uploaded into Karamikis. And so there's metadata about each spreadsheet, and that metadata links to the contributors via their URIs in Karamikis itself. So we are able to connect IDs to collectively to spreadsheets, and those spreadsheets to Karamikis editors. And so that's how we are able to link people to these contributions, and then mint the DOIs through a data site through the University of Virginia Library.
I have not a question, but just a comment here from Asa Larsson. Just wanted to say, great project, very inspiring. We'll look closer at this. Yeah, same here. And then we have another comment from Barbara Löbel. Great work. Also a nice example of a workflow which actively addresses the issue of making the data entry process more transparent and more fair to the contributors, as well as making the data fair. Yeah, I think so. Okay, so if there are no more questions, I will just try to use 1 more minute to do some advertisement, especially for, as we mentioned before, our special interest group, which is called Semantics and Laut in Archaeology, and short SIG Data Dragon. Just show here our website. It's online at datadragon.link. And if you go there, you will get some information about that. And the most important thing is that on the bottom, there is here a dragon sign and a join sign. And this thing here will go directly into GitHub, where you can just create a pull request to this table and add yourself, and then we will hopefully start after this conference. Yeah, nice work on linked open data and semantics and archaeology, and to have a really cool common point to yeah, work on this topic into the next couple of years. So yeah, just want to do that advertisement. And if there are no more questions, there is one also from Asa Larsson. So the Keramikos link to the blog post didn't work. Can you try it again? So even if you just put the link into the chat, that will be great. And so I think we can move on to the next presentation. And this presentation will be held by Mirto Kukuli on reflection of history and approach to enhance documentation of cultural heritage. And yeah, so that means you have now 15 minutes, so until 20 past 1 in Berlin time. So yeah.
Thank you very much.
Forward.
And good afternoon, everyone. First, I would like to thank the organizers for having us here today. So let's go. Several years ago, the late Professor Yannis Akelarakis told me that as archaeologists, we must not only study the facts, but also discover the story behind them. He also said that more than anything else, he felt that he was a good storyteller. To paraphrase his words, you must build on scientific evidence and then create a story. This story is what will make the facts matter. It will give them meaning. The idea behind the current work is to find a way to offer every viewer of a cultural heritage collection the tools to think beyond the description of a monument, to understand its meaning and imagine its story. Our approach is to attempt this by widening the scope of the documentation of the monuments that we wish to present to the public. To do this, we have to first, of course, build on well-structured scientific data, then to enrich this data with scientific inference and connections to other monuments, and encourage visitors to reflect on cultural heritage facts by giving them hints to think on what they've learned. So this is the main idea behind this work, but before going any further, let me first introduce our team and talk briefly about the project that we are currently participating to. So we're a team of researchers from Athens, Greece, affiliated with the Department of Informatics and Telecommunication of the University of Athens, and also with the Athena Research and Innovation Center, also located at Athens. We are mainly a computer science and engineering team, but we always try to follow an interdisciplinary approach in our work. And in fact, I'm personally a pretty good example of this approach, since I hold a degree in archaeology, but I'm currently pursuing a master's degree in computer science while working for the Naira Life team as a software developer and computer science researcher. As a team, we have a long history of participating in European and national projects about cultural heritage. What we do is offer digital tools and technological support to both cultural heritage institutions and also to content creators in order to help them promote their collections and their knowledge. Towards this direction, we design and implement digital interactive storytelling experiences. To sum up, our main goals as a team are first to educate through interactive experiences, also to attempt to reveal the stories hidden behind historical facts, and of course, by doing that, to foster historical empathy in the consumers of those experiences. So now a few words about our the project that we're currently working on. Wojska is the 3-year national project, partly funded by the European Union. Its aim is to promote the cultural heritage stock of Varta, a city in the northwest part of Greece. As you can see, we're only part of the other partners in this project. And it will be based on 3 axes. First, to semantically enrich the documentation of the cultural heritage assets, which include both archaeological sites and artifacts. Then to provide tools for creating cultural experiences of various types, and then to create such experiences and present them to the public. Today, we will mostly discuss our team's work regarding the first axis. And just to give you an abstract view of the software architecture in the project, a digital repository will be created to host the collection. Around this and around a portal that will bring everything together, we will develop a series of applications for creating and presenting multiple types of cultural digital experiences. So let's move on now to the concept of augmented documentation. This concept was cultivated gradually through experimentation and observation. As I mentioned previously, one of our team's main concerns is to discover ways to encourage historical empathy. Through the years, we have established that storytelling experiences are a very effective method for establishing engagement and promoting learning and a more effective connection with the past. Since the project CHESS, we have been continuously experimenting with various types of storytelling and closely observing people's reactions to it. During the project Emotive, we moved one step further and tried to associate selected artifacts with sociological concepts. As a part of some of the project's activities, we asked the visitors questions in an attempt to start a dialogue between them and make them reflect on universal values and situations in human life that are still relevant today. We noticed that this triggered interesting discussions and made the participants want to receive further knowledge on the historical period and the people of those times. Through dialogue, they started creating in their mind their own image of the past. The Voiska project gave us an opportunity to experiment even further by adding these extra elements to the data model and making them available in the project's digital repository. In other words, we want to provide the visitors of the repository with the ingredients that may prompt them to reflect on the past and to create their own story about the monuments that they learn about. To achieve this, we decided to extend the basic documentation, first by adding extra information that place cultural heritage monuments in a particular historical frame and provide other details about their interpretation, and also by adding two types of questions, information questions and reflection questions. The first ones lead to informative content of wider scope, and the second ones aim to trigger the viewer's imagination and emotions. Alongside these elements, we plan to use controlled vocabularies extensively and to enrich the documentation with links to external resources and to each other. So after processing this idea between us, a crucial next step was to make sure that this approach also makes sense to the groups of experts that we think will benefit the most from augmented documentation. Also, it was important to further investigate the various perspectives that they may have on the ways to bring history closer to modern life people, to make them reflect on the connections between the past and the present, and to establish historical empathy. So one of the main target groups, naturally, had to be the cultural heritage experts, and we started with our partners in the Voiska project. We asked them about the data they collect and what they consider important information. Then we explained to them our idea for augmenting the documentation and our overall view on how it could be used. They said that their own goal was to bring the public closer to cultural heritage by organizing various types of activities. They also talked about the importance of bringing out more about the monuments than just their formal description. They welcomed the idea of the reflection and information questions, and they even started working on augmenting the documentation of the artifacts and sites in their collections with much enthusiasm. Also, they showed great interest in controlled vocabularies and in the multiple ways that we can use them to organize, store, and retrieve knowledge. The other two user groups that we believe will benefit from augmented documentation are content creators and educators. By content creators, we refer to the specialists that rely on scientific evidence and knowledge in order to create content that promotes scientific facts in a meaningful and playful way, so that they can be consumed by the public. Educators can also be considered content creators, since one of their main tasks is to prepare content for their students. On the screen, you can see a few highlights from recent interviews with such specialists that took place as a part of the Voiska project, where they were asked about their methodology and things they considered important in their line of work. They talked about the value of making comments and observations about things that are still relevant today and make their audience wonder about their own connection to the past. They also mentioned the importance of emotionally involving the audience and of adding a sense of humor to the content. Also, that they often use questions to create a sense of participation and to provoke a reaction from the audience and encourage them to think on their own instead of passively receiving information. About the concept of augmented documentation, they considered it a valuable tool for making archaeological facts easier to approach, which they consider a key factor to making people more interested in the information they receive. So a few words about the data model. So after receiving feedback from the experts, the next step was to create the data model. Our basic principles for modeling the data were first to keep the model simple, since we considered it very important to find a balance between keeping the model simple so that it can be easily applied, and at the same time, making sure that our application needs are supported. Also, we made sure to follow good practices for linked data to the best of our abilities. Towards this goal, we added properties that are designed to enrich the documentation with links to external resources and plan to use controlled vocabulary extensively, as already mentioned. We chose to use the Europeana data model as our main ontology, with some additions from CDOC CRM and CRM Digital. The most challenging part was modeling the questions in relation to the cultural heritage asset. We chose to consider the questions as annotations of the cultural heritage object. We had modeled the archaeological sites in the collection using CDOC's site class and the artifacts using the physical thing class. So we used the annotation object to model the questions, and they is annotated by property, both from the CRM Digital, to model their connection to the artifacts and sites. Also, as external resources, we decided to use geonames for linking to places, and Wikidata and Wikipedia for linking to events and historical figures. As I mentioned before, we intend to use controlled vocabularies as much as possible as a means to ensure consistency during the documentation process, but also as a conceptual link between cultural heritage monuments and as an additional source of knowledge. We rely on existing controlled vocabularies that we either use as they are or combine them to create our own. So, to sum up our approach, what do we want the audience of the augmented documentation to experience? Our goal is to offer them a digital environment where they can freely navigate and search cultural heritage collections in multiple ways. Also get information about the assets and the historical period, discover connections linking each monument to other monuments or to historical events and figures, to reflect on the past by wondering about values and concepts still relevant today, and ultimately realize the strong connections that exist between people and places and the timeless truths that connect us all to history. In our experience, to achieve these goals, we must always try to first establish productive and continuous communication with the groups of experts we're trying to serve so that we fully understand their needs. Then develop user-friendly interfaces for both the audience and the experts that are in charge of documenting the monuments. Then be very careful not to overwhelm the audience with presenting all the information at once, but try to reveal it gradually. For example, having our model in mind, the viewers of the documentation should first be presented with some basic informative content. Then they can follow internal or external links to other resources. They can choose to unlock further knowledge by choosing to read the answers of the information questions. And they can also get hints for starting interesting conversations or creating their own content by reading the reflection questions. Also, further information could easily be added by linking to the knowledge hidden in our control vocabularies, mostly meaning the definitions of the terms. One other thing important to our team, since it's one of our main research areas, is to try to demonstrate ourselves the value of augmented documentation by designing and implementing cultural heritage experiences that will challenge the visitor's perception of themselves and the world around them. And last, but certainly not least, we must always try to enjoy ourselves in the process, as this is the main ingredient for reaching great results. Thank you very much.
Thank you for a really great talk. And yeah, if there are any questions, please type in the chat. The really cool project. Thanks.
Thanks.
And always the important thing is, yeah, as I said before, to bring this LOD world out to normal people, and because it's a really nerdy stuff somehow, as we all know. So, are there any questions on the content? Would be great. So, just raise your fingers and type in, use your keyboard, and do something. Now you have the chance. We have some minute left. Or you want to use your fingers to hold your cup of coffee. Yeah. and no, it's really long. And, yeah, if you are still here since the first talk, it's I know that the concentration will go down somehow, also on myself. So there is one thing from Dominic Lucas. Thanks. Very important to point out the thin line distinguishing ease of use and detail of information. Okay.
Yes. Yes, and may I point out that this is one thing that we are very careful about. We try to keep the model very, very simple so that we can have a chance to talk about the actual data before transferring them to the repository. The idea is to talk about the data with the specialists, with the experts, in order to clean them as much as possible and to ensure, at least to some point, the quality of the data that we're going to publish. So, yeah.
Okay. Thank you. Any other questions or comments? Nice little hints or whatever. Dominic Lucas says, thanks. Okay. And if there are no more questions, thank you for your presentation, and also for all the others. If you have your presentations ready, somehow in a kind of link or whatever, or just send it to us, and we will put the link in our main presentation here and send it around and make it available in the end. Everybody can see what this very huge data dragon session are about. So because it's really cool that we have 14 talks today. In the last couple of conferences we just had 5 or 6, so it's really cool. So then I will just go over our last talk for this part, and just share my slides again. And this is by one of our co-conveners of this session, by Ethan Gruber, on linked art for archaeological data exchange. And I'm looking forward for that. And if you want to share your screen, Ethan, it would be great. So thank you.
Okay, can you just quickly verify that you see me changing the slides?
Everything okay.
Okay, good. All right, so I'm Ethan Gruber, and I'm going to be presenting with 2 colleagues on linked art for archaeological data exchange using dracones-Improving as the test case for this. So first of all, what is linked art? So linked art, which you can find at linked.art online, is a linked open usable data profile built around SciDoc CRM, but within the JSON LD syntax. This is for optimum reusability, as developers, if you think about it, are actually users. So if you're a museum or an archaeological data set and you would like the general public to reuse your data, developers are very familiar with JSON. And so this is a way of getting developers involved in building on your API without having more specialized knowledge of how turtle or graph data actually works. So it's also a simplified and very well documented profile of SciDoc CRM. So one of the advantages of SciDoc CRM is that it can be used to describe virtually anything. But one of the disadvantages is basically the same, is that two different projects could use the ontology to describe the same sort of object, like a coin, could describe those in completely different models that are actually not very compatible once you aggregate them. So this profile is a documentation that allows multiple contributors to follow the same profile of SciDoc CRM to make the data optimally reusable. And is also community driven, so there's a scientific community of people from both the CRM SIG and other museums who are involved in data documentation and modeling and that sort of thing. And it's also built primarily around using the Getty vocabularies as the core thesaurus system for data interchange. So what does this look like exactly? So you can see here that there's some JSON describing a human-made object. It's classified as a work of art and a painting. So that's basically what it looks like. Of course, this model gets a lot more complicated if you want to include production events and provenance and that sort of thing. But that's generally what it looks like. If you serialize this JSON LD through an interpreter like the RDF Python library or whatever, you can get RDF XML or Turtle back, and then it starts to look something a little bit more recognizable with CRM ontology and properties and class names and that sort of thing. So first of all, or second, what is Keramicus.org? I won't belabor this point too much because there was already a previous talk on it, but Keramicus.org is a collaborative project seeking to define the intellectual concepts of ceramics, starting primarily with Athenian black and red figure from the archaic and classical periods at the moment. But these principles apply to other periods and cultures of ceramics production. So this thesaurus is in Scots primarily, but it's interlinked with URIs from other vocabulary schemes, and the classes and the classes are mostly SciDoc CRM, or they are subclasses of CRM. So it's very integrated with the linked art ontology itself. This URI for a lekathos, which is an object type or a shape, allows you to view a map with the distribution or some example types, that sort of thing, based on data that we've aggregated into the system so far. So looking at one example of a Greek vase from the Indianapolis Museum of Art. So it's a URI, there's a URI for this object. It has a shape of stamnos, it's terracotta. It was painted by an artist named Herminax. It's red figure. It was produced in Athens at a certain time period. And there are other metadata associated with that, images or measurements and that sort of thing. In JSON LD, in linked art, it looks a bit like this. So there's a produced by data object. This has a URI, and this has some properties carried out by the artist named Herminax, and it took place at a place, and it has a time span which has machine readable data in it. And a lot of these Getty URIs here link to Keramikis URIs or URIs in different schemes. Once you distill that down to its basic RDF XML, and getting rid of the human readable labels that are in the JSON LD, it looks a little bit like this. So they're just URIs and literals that form that production event for that base. Getting into archaeological context, so looking at the Ariadne data model as the exemplar here, we have taken some of the principles from the Ariadne data model using the CRM scientific observation ontology as well as the CRM archaeo ontology, and introduced these into the linked art profile as well. So an object was encountered by an event, an encounter event, which took place at Volci, which is in Italy, a common place where vases are found in Etruscan tombs. That type of place is defined in the Getty Art and Architecture Thesaurus. And that find spot, whatever it may be, if we know the precise latitude and longitude or not, is part of a larger geographic entity defined by the Getty Thesaurus geographic names. And so we distill that into RDF, and it looks a bit like this. I want to draw your attention to using Wikidata as a standardized geographic thesaurus. So we map various thesauri into Wikidata as the primary find spot geographic entity. While many institutions may use the Getty Thesauri for their geography, some others may use geonames.org or the Pleiades Gazetteer of Ancient Places, or the Portable Antiquities Scheme in the UK uses the UK's Ordnance Survey geographic URIs. So we use Wikidata to resolve, upon ingestion into keramikis.org Sparkle endpoint, resolve these URIs from different schemes into Wikidata so that we can query, regardless of whether they use Pleiades or the Getty, we can query these items and they resolve to the same place URIs. But we also harvest these URIs back from Wikidata and create metadata that forms a bridge between the Wikidata URI and the other concepts and other vocabulary systems. The other advantage to Wikidata is that their hierarchy, geographic hierarchy model is pretty consistent, and we can reuse that. So one object may say Volci, and then another object, they're not really sure what town it is, but they know it's from Tuscany. So that allows us to query all objects from Tuscany, whether or not it's linked directly at the specific site or at a higher regional level. And then we map these into SIDOC CRM places with SCOS close matches to other URIs, a geographic model that's compatible with SIDOC CRM and the W3C geo ontology simultaneously. And we use Wikidata's Sparkle endpoint to extract that geographic hierarchy. So we go from the very low level site all the way up to the country for the geographic hierarchy. So upon ingestion into Keramikis, we have a metadata entry, metadata interface just for the top level collection metadata. And that pulls the JSON LD, the linked art, from a URI, and then it parses it to map vocabulary terms from the Getty into Keramikis ones if available. It links from the various find spot URIs to Wikidata, transforms it into RDF, and then puts it into the Keramicus Sparkle endpoint for more sophisticated visualization and query. So this enables us to map the distribution of a particular concept in Keramicus, for example, the lekythos shape, based on some of the data we've harvested already from the British Museum, the Fitzwilliam in the UK, and a couple of other smaller institutions. We're able to map out the distribution of finds of lekythoi over time and space, as well as the production places. And to reiterate, this is mainly focused on Athenian black and red figure pottery. The linked art profile includes information on digital images using the CRM dig ontology, as well as IIIF API services and IIIF manifests that facilitate high resolution zooming and annotation of the images, which is probably the next step for us, is to move into image annotation of iconography. And I've started to put together a prototype of an object viewer. So this page is formed by a construct query to the Sparkle endpoint for Keramicus to create a human readable page integrated with the Keramicus IDs, and it's actually a multilingual interface. So if we have labels, preferred labels in other languages for these SCOS concepts, we can render these pages in Greek or German or French or any other language. And the map that you see there is also a Sparkle query serialized into GeoJSON and displayed in leaflet for the production place and the find spot for a particular object. This one at the British Museum is a famous black figure vase by Ezekias. And so in sum, we've built the technical foundations. We really just need more data. So as I said, we're focusing mainly on Athenian pottery, but these principles can apply to other periods and cultures. Some people have reached out about interests in expanding into Bronze Age or other periods, Bronze Age Aegean concepts and that sort of thing. And at this point, I think linked art is starting to take off, and some museums are starting to build JSON LD output, API outputs for their data. So I think we just need more data and more concepts in Keramicus and start to build a much more massive data set of interoperable material. So thanks for your attention.
Thank you, Ethan, for your interesting talk. And as always, I have to say. So yeah, if there are sorry, if there are any questions, just type in the questions in the chat. Yeah, you asked for more data, so yeah, I think I wrote to you. I'm working in a research project on African red slipware, also for Keramicus, and this one maybe we should get in contact because I will do the LOD output out of that. Maybe there will be some cool stuff also because of that. Not that much data, but some data. So,
definitely. So, I mean, I think we're in a position to form working groups that consist of scholars in different fields of ceramic studies. So if there are people interested in African pottery or Aegean or Iron Age British ceramics or whatever, those groups could coalesce into a working group and begin to take control over the production of the IDs, linked data IDs necessary for reusability in their field.
Yeah, thank you. And are there any questions? Hopefully. So there is one question from Anne Klamt. She wrote, amazing, JSON LD is a good approach set from a perspective of a person who does not code. So yeah, I can agree. What do you say about that, Ethan? and also from a coder's perspective, JSON LD is always a good approach because it's all the good things combined, JSON and linked data. So so there's one more question from Barbara Löbel. Can you tell us more about the plans for expanding the framework to include annotations of iconography? Sorry.
Yeah, so at the moment, there's another project called Manto, which I'll post a link to in the chat, which is at, I think it's Australian National University, maybe. It's at an Australian university that's defining all of the mythological and sort of legendary figures of Greek literature, creating URIs for those. And that's kind of the basic building block for building a higher level iconographic thesaurus of mythological scenes. So if we have a vase which depicts a particular scene, say it's Heracles fighting the lion or the Nemean lion or something, if we had a URI for that scene in particular, we could draw the box using off-the-shelf IIIF annotation tools, draw a box around that scene and then annotate it with a URI for that scene. Then that allows us to begin to assemble a large corpus of that scene as depicted on Greek vases, particularly from different cultures and different time periods. And those scenes would link to the individual components of those scenes. So like the Heracles himself is part of that scene. So you can also drill down a bit further into viewing depictions of Heracles in different scenes entirely. So that's kind of what we're thinking on. There are a lot of moving parts to getting that off the ground, and a lot of discussions among the ancient world linked data people on actually moving forward with iconographic thesaurus for Greco-Roman mythology.
Thank you. Are there any other questions? Just wait some more seconds if something appears. If not, I can just say thank you to all the presenters in this part of the session. It was part 2, and there is one part left. I just will go to my presentation here. As you can see here, normally we have a lunch break, so this will be a short lunch break because it's just 15 minutes or something like that, or maybe 20, and then there is one more talk after that by Espen Ulbjerg about linking datasets in Norway, and that will be cool if you will be there, all of you, just to hear this one talk. It's just to finish this very interesting and popular session. And just Barbara Löbel just wrote, thanks, this is very exciting. Hopefully something similar can be done for numismatics as well. I think so, because even you're also
Right, Ulrika, Peter, and other people are parts of these discussions. So the iconographic thesaurus would apply more broadly beyond ceramics to other objects as well. So definitely.
Okay, so thank you all, and hopefully we see us in 17 minutes or 16 minutes in the other room, which is called Hic sunt Dracones Part 3. And just to listen to our last talk on data sets in Norway. And that's it for now. Thank you. Keith?
Thanks. I just said thanks, Florian.
Okay. So